Hey, good afternoon. Here to talk about rShiny. I'm just going to give you a little bit of a taste of what rShiny is about. This is not going to be an in-depth tutorial, but I will give you pointers to that material if you are interested in learning more. So what is rShiny? rShiny is interactive web applications around your R analysis. And just to make it very clear, rShiny is not a general purpose web application framework. It's not for building an e-commerce site to sell t-shirts, something like that. It's specifically designed for our users who are doing data analysis to create interactive versions of that analysis. And a lot of the choices that we've made along the way really make it very, very nice for that particular scenario. And one of our most important principles is that zero HTML, CSS, and JavaScript knowledge is required. And in general, we want to empower everyone in this room, whether they've been using R for a month or for 10 years, to be, for rShiny to feel like a perfect fit for them. There's no technology that we expect you to go learn. You can start from your R scripts that you're already writing today, and with a few relatively simple functions, you'll be creating powerful interactive applications and documents. Now that said, I've been creating websites since 1996. I'm not a stats person. I'm a software person. And I didn't want to create a framework that made me feel like I was limited in what I could do. So rShiny is also designed for you to be able to take all your HTML, CSS, and JavaScript knowledge, if you have it, and be able to customize and extend the framework. And importantly, you can then take all that cool stuff that you extended rShiny with and offer that as an R package so that other R users who don't have the same skills as you do can benefit from that work as well. And I'll show an example of that in a moment. We have a modern web UI with attractive defaults. I feel like that's pretty standard these days, maybe less so when I created this slide. And it's designed to integrate with existing JavaScript libraries. And as several presenters so far in this conference have shown, there are just really, really cool things happening in the JavaScript world. Ramnath in particular is I think, trying to single-handedly bring all of them over to R. We want rShiny to help be a part of that story that makes it possible to connect the power of R in terms of its statistics and computing and combine that with the really incredible rich visualizations that are possible now in JavaScript. It uses a reactive programming model which allows dramatically simpler code than traditional UI or web programming. I would love to spend an hour talking about this. It's not going to be the focus for this talk, but we have lots of resources on our website. I really love this reactive programming model. As I said, I've been creating websites for a long, long time, and this is really a beautiful and elegant and general and robust way to create very interactive applications. And I'll show you a little bit of a sample of this in a moment. Applications can be deployed to the cloud, or they can be run on premises, within your organization, and you can also run applications directly on your on your desktop computer. We have a vibrant and active community. And I think that's really important because rShiny is designed for people to be able to build on each other's work. So people can create components and things like that in rShiny and let them be reused by other people. Okay. I don't really know how to give presentations. I just go straight to demos. That's my language. So let me show you a quick example here. And a lot of people have been bagging on Iris for some reason. I really don't have a lot of imagination when it comes to these things, so I'm using Iris as well. So here is Iris with a little bit of k-means clustering applied. So on the left, you can see we can choose the x variable and the y variable and the number of clusters. And you can see here, if I change these values, they change. I can change the number of clusters, and it redraws, and the color specifies the cluster, and the X indicates the center of that particular cluster. So this is about as simple as it gets in rShiny, and I just wanted to show you, not necessarily to go line by line through this, but to show you that it really is nothing but R code, and it is relatively straightforward R code for what we were able to just create. There are two files that are involved in any rShiny app. There's a UI.R file and a server.R file, and you put them in a directory, and that directory is now a rShiny application. And the way it works is that the UI file is how you lay out what the actual interface is going to look like, the user interface. In this particular case, we are using this page with sidebar template, but we could be using anything. And this page with sidebar takes 3 arguments. It takes a header panel, a sidebar panel, and a main panel. And that corresponds to these 3 regions on this page. We've got the header area here, we've got a sidebar, and we've got the main area for the output. And within each of these areas, you have a pretty straightforward, either a piece of text or control. So we've got a title here, and then we've got some inputs, and then we've got an output. And on the server side, in server.R, we're going to specify the calculations that R should perform at runtime to take the inputs and generate the outputs. The inputs are available using this environment-like object called inputs. So if I want to get the x variable here, that's called input $xcall, input $ycall, and you can see here all I'm doing is subsetting the iris database, the iris data frame, and I'm assigning that to this selected data variable. And then I'm just calling k-means with, again, an input that indicates the number of clusters that I want. And then finally, I'm doing plotting here. And the important thing to note is that this is all just normal-looking R code. This is the kind of R code you already write. You filter data, you perform analysis, you create plots. And the only things that are a little bit different are these keywords here, reactive, reactive, and render plot. And those are there essentially for you to tell rShiny that this is an expression that's inside of the reactive function. This is an expression that needs to be kept up to date as the user manipulates the user interface. And I'll just show you a quick example of that. So we're running this application in what we call showcase mode. It's a mode that you can run any rShiny application in. And on the right, you can see the code, and on the left, you see the application. And when I change one of these x or y variables, I have to re-subset the data, I have to re-cluster, and then I have to re-plot. And you can see that that code actually, all 3 of those code chunks light up in yellow because they all need to be executed. Now, if I want to change just the number of clusters, not the set of data that I'm plotting, then all that needs to be updated is the clusters and the plot. I don't have to re-subset the data. And that's really reactive programming at work. You have to just add a couple of these little reactive keywords and let rShiny take care of figuring out what code needs to execute when. Okay, so that's a pretty simple example. Let's move on to something a little bit more substantial. There's an article in the Washington Post a few months ago about super zips, super zip codes. And what they did was they took all the zip codes across the US and compared them along 2 axes, along the level of education of adults over 25, the percentage of them who have a bachelor's degree, and median household income. And for those zip codes that fell in the top 5% when you combine those 2 scores, they call them super zips. And once you start looking at super zips, you can find some interesting things. For example, that they tend to cluster together, and that many kids might grow up never really spending a lot of time outside of a super zip. And what kinds of implications does that have? And you can look at their level of health and all these other things. And I thought it'd be interesting to see if we could re-implement this idea of super zips using Shiny, and this is using the leaflet library that luckily is working for me a little bit better than it was working for Gordon a few minutes ago, fortunately. So you can see here that there are a lot of red dots. Those indicate zip codes that are not super zips, and the radius indicates the population. There are a fewer number of blue dots, and those are the actual super zips. So I can use these controls over here to change the color to mean something else. Like, for example, instead of just showing a binary, is it a super zip or not a super zip, I can change it to show, to reflect the centile score, and it'll redraw all those points with a gradient instead. Underneath here, there's two plots. I've got a histogram showing the superzip score for just the zip codes that are visible inside of the map right now. So if I'm looking at the sort of northeast tri-state area here, you can see that there are quite a lot of zip codes that are in that top bucket, but if I move around to, who should I pick on today? Let's do Michigan. Especially as you get away from the sort of major metropolitan areas, that you see a very different picture. And down here, there's a scatter plot that shows education along the bottom axis and income on the vertical axis. And this is normalized to sort of the domain is fixed to the entire country. So if you're clustering down here in the corner, it means that it's pretty low income, pretty low college. So all of this is written leveraging this JavaScript component called leaflet, but I wrote the leaflet binding so that you as an R user can do all of this with no JavaScript at all. And indeed, if you look at the code, I'm again not going to go too much into detail here, but here's the server-side code. It does things that you do in R. We're subsetting, and we're saying we only want points within these ranges. We're making a histogram and a scatter plot. So it's all very familiar stuff if you're an R user, and the JavaScript and all those things are hidden from you, and yet you can have a pretty sophisticated result. Okay, and then really quick, I just wanted to show an application by a guy named Vincent. I'm not even going to try to pronounce that. He, as far as I know, has zero experience with web development and was one of the earliest Shiny users, and he was so excited that finally he could realize some of these ideas that he had with creating user interfaces using R. He's a professor of some kind of marketing or something, and he came up with this fun little app called Radiant. You can see here along the top there are many different modules that he's built. I just explored this a little bit, but you can select a number of variables here and then look for correlations. And there's all these modules, and every one of them does something that I don't understand. Now look at what GitHub says about the languages used here. It is 97.2% R and 1.5% JavaScript. I looked at that JavaScript, and it was questions that he had asked me on the Shiny Discuss mailing list, and I had sent him back, here's a general purpose way here's a component for doing what you want to do, and he just dropped it in. So there's no JavaScript that's custom specifically for this application, and then a little bit of CSS sprinkled in. I was amazed at how sophisticated an application he was able to come up with no background in web development. Okay, how am I doing on time? Okay. I'm just going to show one more demo. This is a demo of a new capability in rShiny and our Markdown in our studio and pretty much every other package that we work on. We've had a project for the last several months to bring a lot of our technologies together to make rShiny documents or interactive documents. And what this does is it lets you start with an R Markdown document, which hopefully many of you here have used, and add the interactivity of rShiny with so little effort, we were kind of astounded. So this particular example shows a visualization of logs of our CRAN mirror. So our studio, the company runs a pretty popular CRAN mirror, and we make all of the download logs for those mirrors public. They've been running since the beginning of 2013. So this application lets us search for different packages and see how their downloads compare to each other. So I've got a period of the beginning of this year to a couple days ago, and then I've specified 3 packages that all have something to do with bugs, and I want to see which of these is gets more downloads than the others. And you can see here it works, and we can compare that now, let's say, to some very popular packages, and let's try Flyer. And we can see how they compare. Oh, well. I didn't know that was what that was going to look like. I apologize if the author of these packages are here. Sorry, I'll buy you a drink later. Now, this state has been smoothed, and as you guys know, if you smooth, depending on the level of smoothness you choose, you can really affect the story that's being told. So rather than, as the author of the report, choosing that for you, I want to let you, as the reader of the report, decide for yourself what level of detail you want. So if we take the smoothness level way down, you can see these very, very spiky patterns. And what we're seeing here is you guys not working on the weekends, I suppose. And I think for most cases, that's a little distracting. So if we take it up, we can make that go away. So if you look at this code, it really looks a lot like a normal R Markdown document. You've got your narrative, you've got your chunks of R code, and what you can do is, instead of just outputting tables and plots, you can output inputs. So these are the same inputs that you would use in a rShiny application. You can output them right here, and then you can have those same reactive expressions I talked about, and you can just drop plots in using this render plot command, and it will not just plot it once, but plot it as often as necessary to keep it up to date. We really think that this might be the very easiest way to get started with R. In fact, this is the way we're going to, the easiest way to get started with rShiny, and in fact, we are modifying all of our training materials to start with this mode of using rShiny, because we find it's so natural for people who have used knitr and R Markdown before. Okay, we have quite extensive training materials here. We've got a tutorial that is quite involved, or quite easy and comprehensive. We have a lot of articles, and we have so many example apps. This is weeks of my life right here. But hopefully you find that useful for creating your own apps. So again, that is at rshiny.rstudio.com, and we have a very, very active mailing list at rShiny Discuss if you have further questions. Or you can ask them right now, actually. Yes?
Is it possible to use external data as input in rShiny application instead of the user?
Is it possible to use external data as input instead of user data?
It gets updated like every 30 seconds.
Yes, in fact, I almost could have paid you to ask that question because Shiny works incredibly well for that case. This reactive programming paradigm, what I've shown is user inputs causing these kinds of things to change, but it works equally well if the source of things changing is a file on disk changing, data in a database changing. We've got stuff about that on our website. And I actually don't know an easier way to do this in R than using Shiny's reactive framework. And in fact, if any of you were here for the GGBiz talk, he showed some of that stuff. I mean, just making fake data, but still that you can see data changing over time, and none of your code needs to worry about that. It just re-executes. So yeah, that's a great question. Yes?
Can you interact with graphs?
Can you interact with graphs? Yeah, you sure can. If you are doing normal base R graphics, when you create an output, when you create a plot output, you can say, by the way, I actually care where the mouse clicks, or I care where the mouse hovers. And that's accessible as just another user input. And we have a couple of demos of that. Unfortunately, it doesn't work with ggplot2 because it uses grid, and that messes up our world. But there's GGBiz now, which is a much, much more integrated way to do that. So it's also possible in that way. Yeah.
So following up on the other question, what about users uploading their own data sets?
Yes, what about users uploading their own data sets? We make it extremely easy to upload a single file, or multiple files. Yes, okay, so we have a file input, and you can just drop that on your page. And in fact, Mr. Vincent has an example of this. So he's got some, you can pre-select some data sets, or you can just upload your own file. And this shows up to you basically as just, here's a file on disk, and you don't have to worry about how it gets uploaded. So I think that's probably the time that I have. Yeah, okay. Great, thank you.